Problem Session 8, Question 2. Let x and y denote respectively the lifetime in years of an engine and suspension system of an automobile. The joint test function of x and y is given as this. And it asks to find the marginal PDF of x. So to find the marginal of x, we need to integrate the joint PDF over all y. Let's solve it. Equals 0 to infinity minus x e to the power of minus 2y dy. We need to integrate over y to find the marginal PDF of x, and it is equals to the power of e to the minus x integral 0 to infinity e to the minus 2y dy. This is 1/2, and it will become e to the minus x 0. Okay, section B. It says find the marginal PDF of y. To find the marginal PDF of y, we do the same in other direction. Integrate over all x to get the marginal of y. Let's solve it. We have y equals integrate over 0 to infinity to the power of minus x e to the power of minus 2y dx. We need to integrate over x equals to 2 multiplied by e to the power of minus 2y integration 0 to infinity to the minus x dx, and it's this part is equal to 1, and the answer is 2 multiplied by e to the power of minus 2y, and y greater equals 0. Part C. Find the probability that this automobile will not have any problems due to the engine or the suspension system, namely probability of x greater than 1 and y greater than 1. So we need to probability that both the engine and the suspension last more than 1 year. To get that, we adapt by integration the joint tensity over every pair of xy where both x greater than 1 and y greater than 1. So in the first step, we need to write a double integral, so which means probability of x greater than 1 and y greater than 1 is equals to double integral x equals 1, y equals 1 to the infinity, and write the function in here. I've just copied the joint PDF to multiply by e to the power of minus x and e to the power of minus 2y, and set the lower limits at 1 because that's our more than 1 year condition. Okay, in the second step, we need to integrate with respect to y and keep the x fixed. What I mean is we need to solve this part. Integration over 1 to infinity e to the power of 2 minus y dy equals to the power of 2 multiplied by e to the power of minus x minus 1 over 2 e to the power of minus 2y infinity to 1, and this is equals to e to the power of x e to the power of minus 2. In the third step, we need to integrate the remaining part over x. What I mean is, we need to find this now. I just moved here, moved this function into the integral. Since this part is constant, I just moved to the outside, and this is the part I need to integrate. Okay. This equals to and this is approximately 0.0498, we can say almost 5%. So there is roughly a 5% chance both parts survive the whole first year. Part D. Find the probability that this car will have an engine problem in 4 years, namely probability of x less than equal to 4. To find the chance the engine fails within 4 years, we start with its lifetime PDF, and it was e to the power of minus x for x greater than 0. We need the area under this curve from 0 to 4. So we write probability of x less than 4 integrate over 0 to 4 e to the power of minus x dx. Let's solve this. One minus power of minus 4, and it's approximately 0.9817. Can say it's roughly 98%. So we find that there is roughly a 98% chance the engine will fail at some point in the first 4 years. Part E. Compute the probability that the engine fails before the suspension system fails, namely probability of x less than y. Find the probability that the engine fails before the suspension. We have to find this one. We integrate the joint PDF overall x greater than equal to 0 and y greater than equal to x. So we can write integral x equal to 0 to infinity and y equals to x to infinity to the power of e minus x minus of e to the power of minus 2y dy dx. First we keep x fixed and do the inner integral in y. Let's write it out. To the power of minus 2y dy equals to infinity as you can see e to the power of minus x is constant in y. So it becomes multiplied by e to the power of minus 2x, which is equals to e to the power of minus 3x. That reduces the double integral to a single one. Finally, we can calculate the probability of this by calculating this integral. So there is 1/3 chance the engine fails before the suspension. Part F. Are x and y independent? To check whether x and y are independent, we use the criterion that they are independent exactly when this rule holds. Let me write the rule. From part A, we found equals e to the power of minus x, and from part B we found equals to the power of minus 2y. Multiply them gives us this joint PDF. Since the product of this marginal equals the joint PDF everywhere, we conclude x and y are independent.